Hey, this is Colin, AI6BH. Hopefully you watched the previous video demonstrating the HamLib-Web utility they put together. And this video is really just to explain how it all works and hopefully get yourself up and working with the same stuff. Now, obviously what you need to do is connect up a computer running the HamLib utilities to your radio first. The stack that we're going to be using is this stack up here. This is the IC7100, and the antenna tuner above that's a remote rig box, and then right at the very top there is a Raspberry Pi. It's probably easier for me to show you some of that stuff with some pictures I took earlier. So let me see if I can just share the screen and run you through that. So there we go. And we'll get up PowerPoint, and I think I have some of those pictures here. So let's start from the beginning. So yeah, this is my radio room. It's just down the hall from me, and I've got a bunch of radios there. And you'll see that not too many computers there, but a bunch of radios. And this is the stack that I was talking about that I can actually manage remotely when I'm in my office here. Via the remote rig box, which is this little tiny box here, and up on the very top is my Raspberry Pi that actually manages all this stuff. This is my hobby. I spend a lot of time on radios and playing with them, but at work I'm a network guy and like playing with networks and stuff. So underneath this desk, you'll see all my networks. This is how I actually interface to the head unit of the 7100. There's no head unit in the ham shack. So this is the ham shack, and this is what I use. This is the IC7100. This is the remote rig box, and the remote rig box connects into my office where I've got the other end. This is by Ethernet cables at the back. And this cable here goes to the head unit, which is sat on my desk right next to my keyboard where I am now. So it means I can listen into stations. And what I really wanted to do was take the frequency I'm listening on here and then put that frequency and the operating mode up on my website, my Wavi site that I showed you earlier. And obviously to do that, what we've got to do is interface the IC7100 with HamLib and then get it out onto the web. So the first thing you got to do then is obviously join up the Raspberry Pi that I'm using in this case via USB, and that USB cable goes into this socket on the 7100, and at the other end it connects to the Raspberry Pi, and on the Raspberry Pi you'll be able to see those they actually show up as serial interfaces, and then you'll be able to talk to the rig directly. So it's probably easier just to show you how that stuff works. I've got the radio on right in front of me, and we'll show you that in a second. I'll show you up and running, and let's go stage by stage. We'll just clear the screen, make sure this is less confusing. If you go to my GitHub page, I'll put that back in the comments or in the end titles, so you don't miss it. You'll see essentially you've got to use the HamLib project and you've got to install it. So down here there's some instructions on how to do that. I've already done it on my Raspberry Pi, but it's pretty easy to do. You can go to the HamLib project pages and download the tools directly there. But most distributions, if you're using Ubuntu or Pi, you'll just be able to run this command and they're actually install all the command and utilities for you. Takes a second or two just to install that. And then you'll be able to see, first of all, which serial port the USB connection actually looks at. So I'm going to copy this command, run it in my Raspberry Pi, and you'll actually see that I've got 4 serial interfaces here. They're all they show up as TTYs. So this is just doing an LS dev TTY USB, and USB 0 and USB 1 are actually my FT991A, and these are the cat and the controls for the FT991A, and the USB 2 and USB 3 are actually the cat interfaces to the ICARM 7100. So we're actually going to use a USB 2. So most of the instructions, or in fact all the instructions in the HamLib we're not using anything I've put together here as yet. So there's the next command. Make sure you can actually talk to your radios. Good thing to check. These things are pretty self-explanatory. The only things you'll probably have to change are the -M and 370. 370 just tells read control which radio you're connected to. 370 is the number for the IC 7100, and then obviously, depending on your setup, your USB number may be different. The first one that'll come up is USB 0. In my case, that's the first radio I've plugged in, and then it's just a connection speed. So if we actually connect to that, it'll say read command. So we just bring down a camera that's got a screen, and you'll be able to see what I can see. Just resize that a little bit so it's not too big. There we go. So there's my desk, and there's 7100. So the read commands, a protocol here to the read control command is actually pretty simple. It's lowercase f, and that will give back the frequency. So it will give back the frequency in hertz. So if I change it to 144.225, if I issue that command again, F, you'll see it's 225. Now, you can also look in the operating mode. At the moment, I'm on USB, and obviously if I change that, let me just change it. Let's change it to FM, and I do operating mode. Again, you'll see it's FM. So everything's pretty sweet. It's pretty cool, but it's not network connected. This is just a local command line running on the local Pi. And what's very cool as well is you can actually control things as well. So with an uppercase F, I can actually change the frequency. So you can see I'm on 225 at the moment. Let's change this back to the 220. And I hit F and look at the camera screen. As I hit it, you'll see it will change. So what's happening here is I'm running this command. It's talking to the USB port. It's talking over cat and sending the right cat commands to interface with the radio, which is pretty cool. And that's all the work that team's done over the years to make all that stuff happen. So that's good. We've now got an interface between the Raspberry Pi and the ham radio. So we know it's working. So that's great. But what we've got to do now is interface that with our Adsign. So first of all, in full disclosure, I'm one of the founders of the ad company. The ad company is adsign.com. And we've invented a new internet protocol that uses these ad signs that just identifiers on the network, and people can own their own data behind those ad signs. And in this case, as I showed you in the previous video, I own AI6BH, and it means I can control everything that's on this page through an app. But what I didn't show you is actually the app. So what I wanted to do next was actually show you that app. And again, I'll share my phone. And I'll bring it down here. Here we go. This is my phone. It's an Android phone. Works equally well on Android or iOS. And we've got a bunch of applications that use the app protocol, but the one we're going to use today is the Wavi. And you can see it's configured with AI6BH. And that's because I own that ad sign. Nobody else in the world has got AI6BH, just me. If you want to add a new one, you sign up on adsign.com, and you pick the one you want to get hold of, and you type it in here, and you'll type it in, and it will ask you for commitment via an email address. Or if you just want to generate a free one, you can actually generate a free one, and it will give you some choices for a free one. So you don't actually have to have one that you chose. You can just pick up a free one, and you can pair it and all that. But we're going to ignore all that stuff. We don't actually need that. But you may need to do that because you haven't got an ad sign yet. That's fine. So you get an ad sign. Everything's good. It will ask you to save some keys, and those keys are important. You'll see those. Where those go in the moment. They're in a moment. They're your cryptographic keys to actually interface with the backend platform and actually update information. But so if you forget to do that, you can click this little button here, and it will ask you where you want to back up your secret keys. And those keys are actually generated on your phone, so you don't want to lose them, because anybody at that company can't restore them for you. They're your keys, they're your secret keys. They were cryptographic keys generated on your phone. So let me just show you what this does as an application. Obviously, we can hit the eyeball and that will view the page just like the web page, and yeah, we can see that. And let's go back. And if I want to update something, I can update it in here. There's some control panels here. I can update any of this information, hit the save button. It will save it locally on my phone and then sync it up to the web, and the web page will be updated. The neat thing is that this is all under your control and cryptographically signed by you and your phone. So we always know that it's your data, nobody else can play with it. But what's important here is that you grab the keys, and you'll see that as we go to the next stage, you'll need the keys to set up the interface between your Raspberry Pi and the app protocol. So that's how you fire that up. Again, I'll put the link to the Android and iPhone applications in a minute. I'll put those at the end of the video for you. So let's go back to the instructions. Now we know a little bit more about that. So you got your @sign, that's all good. What you need to do at this stage is actually clone. You go to your home directory, presumably that's a good place, or somewhere in your directories, and actually clone this repo. That's actually all the code you'll need to run all this. I've actually done that already. Let's go back to my home directory, and I'm going to cd into HamLib-Web, and you can see these files. Once you've used Git, if you've never used Git before, all it does is copy the files in the Git repo. All of these files in the repo, and it will actually, if you view the code, it's all of these files. It will actually copy all these files to your directory on your machine. And if I update anything, then you just need to do a git pull and actually update all your files, so you don't have to do all that stuff manually. So once you've done your git clone, what you actually need next to build one of the tools, and one of the tools we use is called @CLI. So that's actually a command line interface to the @ and that will take your keys, your cryptographic keys, and update your page. So it's only you and this Raspberry Pi in the world can actually update that page, but you have to build that tool. To build that tool, we actually use Docker, and it has to be above 1903. So if I do Docker version on the Raspberry Pi, you can see I'm pretty up to date. So if you haven't installed Docker before, there's a few clues on how to do it. This is probably the easiest way to do it. I would actually not use a distribution, install the Docker distribution. It's probably not up to date. But if you run this command, followed by this command, this will actually install Docker, and you'll be able to run the same as I am, Docker version. And then you're going to be in a position to build the @CLI. So we try to make this as straightforward as possible. @CLI uses something called Dart. It's all programmed in Dart, and if you're interested in all that stuff, you can actually go to adsign.dev, and there's a whole bunch of instructions on how to program on the app platform. But maybe you don't want to do that. Maybe you just want to get this thing up and working. And if that's the case, we've got you covered. I just cd to HamLib-Web. This is where we are here, and you run this command. Build @CLI. So let's do that. And what this will do, it will build it, and that's it. It's built. In my case, that's because I've run all this stuff before, and it will actually generate the @CLI command line tool. And you can see there it is there in green, @CLI. So that's actually the tool we need to update but what we also need to do is get that key file I mentioned earlier. And the key file looks like this. You've got to drop it into the right directory. So what many of us have used is use WinCP. If you want to drop that file on your PC, drop it on maybe a shared drive on your Android or iOS device where you've got that key file, and then copy it across onto your Raspberry Pi, and then tidy up afterwards, because that key file is really important. And you'll be with the key file can actually update your site, but it's without it, you just can't. It's just impossible. So if we just cd into the key directory, you'll be able to see, this is mine. So it's got the @sign and then the key and then .@keys. And it's actually a text file. If you look at, you're welcome to look at it, but it's full of cryptographic long numbers. I won't bother showing you mine, but that's in good position. So we can cd up to the directory. So I've got the key file in position. That's good. The next thing is to copy a config YAML file. This actually tells all the commands that we're going to run in the background to update where everything is. So I'll show you mine. So we'll just copy this. And, go into editor Vi. And here it is. It's pretty straightforward. You can see I'm just copying over an example we give in the repo. So when you do the Git clone, you'll get this example file, and it's just copying over, and I have some examples in. So lots of the stuff you don't need to worry about, it'll be pre-filled, but this is the port number and the root of the app protocol. Don't need to worry about that. It's the same for everybody. And then really the most important things you got to change are your @sign. In my case, it's AI6BH is my @sign, and then the location of the key file. And that's what we just did. And once you change those two things, you're in good shape to go to the running part of this, so we can start our engines. So I tend to use tmux. Tmux is a terminal multiplexer, and what that means is that you can have sort of long-running terminal programs and actually go back and see them, see how they're working. And if you like to keep an eye on things, rather than having a background daemon that you may or may not know what's happening with them, you can actually use tmux to see what's going on. So I'll show you how to do that in a second. It's pretty straightforward. And then we actually need two programs running. We need a rig control D, which is a daemon. It's basically the same as the rig control we saw earlier, but it's running as a daemon and listening on a port. I'll show you that. And then we need to run this other command called sync Wavi, which does what it says. It synchronizes what input we get from rig control and syncs it to your Wavi page. So let's go into tmux, and we're attached here. And this is tmux. So actually, tmux allows you to have multiple windows on the same command. Although I've got two prompts here, they're actually in the same command, and I can switch between them. If I hit Control B and then an arrow key, I'll be in this one, and then Control B and the arrow key to go over there, and I'll be in this one. So I actually have two prompts, but actually only one command. I can get back out of it, and I can get back into it. So it means you can have sort of background processes running, but from the command line, but actually see what you're doing. So in this window, what we're going to do is run this command, and again, it's in the notes. And you can see all it's really doing is saying having a wrapper around rig control D. So while true, it's going to run rig control D, and we've seen this command before. It should look similar. And if that crashes, now in the case of rig control D will crash because everything eventually will crash. It will sleep for 5 seconds and then start itself up again. So this is like a fail safe, just in case rig control D does fail. It'll wait 5 seconds, wait for everything to quiesce, and then it will start up again. So that's why I wrap it around in this while true. Don't have to do that, but if you do, then it sort of guarantees that rig control D, if it crashes, it will come back up again, which is quite nice. So we're going to hit return on that. And you'll see that now it's awaiting. So, what does that bit do? It's exactly the same as rig control, but it's got this D. And what the D does is puts into a mode where it actually is answering TCP connections. And let's just show you how that works. And you'll see that earlier I mentioned it, I didn't mention it, but there's this -T command. The -T actually is the port number it's listening on. So if we change this other command line and we telnet to it, let's just use netcat. I'm pretty sure I got netcat installed on here. We're going to 127.0.0.1 and port 7100. So we should connect to it. And you can see, yeah, it's opened up the model number 7100, and we can hit those commands again. So F. Yeah, well, that looks right. See if I can bring down the camera for you again, so you can see what I'm seeing. Here we go. Here we go. So again, a little bit too large. We should be able to change it for you. There we go. We should be able to see everything. Right, so at the moment, we're on 220. Let's change it up to 225 and do an F again. You see we're on 225. So this is where we're going to get their information from. And obviously it's all working just fine. But what we're not doing here is actually updating Wavi. So we've actually got to run another command. You can see as I hit Control-C, it's closed the rig connection, and it's waiting for more clients to connect over TCP/IP. So that's all well and good. We're in pretty good shape there. Let's go back to the instructions. And I think we'll find the instructions will say, there's the while true rig control D as I showed you. Now what we've got to do is just run the sync wavi.sh script. And one thing we need to do is just have a look at the env file. So there's an env file that we need to look at just to make sure that's up to date. So again, we've got an example. We just copy it over. Let's just look at that. So if we vi.env in capitals, you see there's some. Move this down for you. There's some sort of just housekeeping rules. So first of all is the IP address of the place where the rig control D server is. You can actually run the watch on a completely different machine. Doesn't have to be running on the same machine. In my case, we are running on both these things on the same Raspberry Pi, but it doesn't have to be. There could be, you could actually run the watch on any other computer. So it needs to know what the IP address is, and this is the IP address of the Raspberry Pi in my case. It needs to know the port number. Obviously, in our case, we're using port 7100. Doesn't have to be 7100. You can change it in this config file. And we've got a timeout. I give a timeout of 1. That's 1 second, just to make sure that if there are any connections, then if they haven't been answered in 1 second, then probably the rig's off. So that's pretty easy to set that sort of stuff up. But again, if you want to change those values, feel free to change those values. None of that's set in stone. That's in the environment file, so you can change them. So let's go back into instructions here. Once we've done that, then all we really need to do is run the sync Wavi command line, which is this one here. So we'll just copy that. You actually see it in this directory. I have to put a / on the front of it because it's not in my path. And we hit enter. And you can see it's actually connecting. And what it's doing, it's found the frequency is 225.0.0. The mode is USB, and it's done an update to the Wavi page. And this is a commit ID to the Wavi page. Now, you can see it's polling every second. It will poll to make sure that we haven't changed anything. But you'll only actually update if something's changed. So we don't actually update the page unless it's changed. It's not continually updating. So if I just show you that, if I get up the camera again, there's the camera. And you should see the whole thing working in unison. If I get the There we go. So we're on 225. Let's move up to 230. You see we've moved up to 230. The sync Wavi has noticed we've moved up to 230, and it's spoken to my Wavi page, and there's a commit ID. We go to my Wavi page, and we refresh this. You see I'm on 230. If we move this back down to 220, you see the commit ID has been done. If we refresh this page, so everything's in sync. And if I switch this off, there we go, the rig is off. And we see that the rig's been switched off, and there's a commit ID. So if we refresh this page, then I'll be QRT for now. So I think that gives you a pretty good idea of how to get everything up and working. It's pretty straightforward. If you do have any issues, then feel free to reach out to me directly. That's absolutely no problem at all. This is on the GitHub page. You can raise an issue, and we'll work through the issues with you. Again, thanks for watching. Slightly long video. I'm sorry for that, but lots of things going on, and undoubtedly I'm building on the shoulders of giants with all the HamLib stuff. But I think it's pretty interesting to be able to advertise to the rest of the world via a web page what frequency and what mode you're on. Hope you found that interesting. Thank you so much, and we'll hopefully catch you later on down the log 73. This is AI6BH.